A gun fires, signaling the beginning of a race. Runners begin sprinting down the track toward the finish line. Moments later, one of them passes before all of the others. Now, in your role as official race tracker, you learn that the speed of each runner was identical. But how could this be? Isn't that inconsistent with the fact that one participant finished well before the rest? Well, no. And that's because speed is not the only thing that determines the winner of such a race. Each participant's starting distance from the finish line relative to other competitors also matters. My name is Justin Schieber. Welcome to Real Atheology. Make sure you hit that like and subscribe button to keep up with our content. Now, what did that introduction have to do with the philosophy of religion? Well, just as speed is not the only thing that determines the winner of a race, the extent to which a theory can account for the data is not the only thing that determines its probability. In a paper titled God, Evil, and the Nature of Light, philosopher Paul Draper notes, quote, "The probability of a theory depends not only on evidence, that is, on factors extrinsic to the theory that raise or lower its probability relative to some prior or initial probability, but also on intrinsic factors," unquote. By intrinsic factors, Draper is referring to factors having to do with the content of the theory. The story then illustrates the crucial importance of taking into account factors an explanatory theory has from the get-go, long before we begin surveying the evidence for or against it. And when we attend to these, we quickly notice that not all theories are created equal, intrinsically. And so this brings us to the concept of intrinsic probability. Instead of referring to the probability of some theory prior or independent of some body of evidence, the intrinsic probability of a theory is the probability prior to or independent of all evidence. And so we can think of intrinsic probability as a kind or category of prior probability, the question being, prior to what? Now, for this episode, I'm going to present one account of intrinsic probability. Specifically, this episode is going to be a brief overview of Paul Draper's theory of intrinsic probability. This theory has three main tenets. First, the intrinsic probability of a theory depends on its modesty. Second, the intrinsic probability of a theory depends on its coherence. And third, there's nothing else on which a theory's intrinsic probability depends. Now, although the phrase intrinsic probability makes use of the term probability, this should be understood somewhat loosely. We're not going to be plugging in numbers into some formula to learn the exact intrinsic probability of a theory, but that does not mean that they're useless to us either. Indeed, in most cases, we're going to be quite limited to using them comparatively. This theory is more intrinsically probable than this theory. Of course, some theory comparisons are going to be quite obvious, while others are just going to be too close to call. But none of this is a problem for the basic claim that intrinsic probability matters to theory comparison. According to Draper's theory, the first intrinsic feature of a hypothesis that in part determines its intrinsic probability is its modesty. So what is modesty in this context? What does it mean to say that one hypothesis is more or less modest than another? Well, modest is not a measure of how revealing an outfit worn by the hypothesis is, nor is it a measure of a theory's lack of arrogance, though this is a much closer interpretation. Rather, the modesty of a hypothesis has to do with the size of its content. Put another way, it's a measure of how much the theory says. Specifically, the modesty of a hypothesis is inversely related to how much the hypothesis says that could end up being false. In other words, the more a hypothesis sticks its neck out, the less modest it is. But why should anyone think that modesty understood in this way should matter to intrinsic probability? Well, Draper writes, quote, "The less one says about the world in this sense, the less room there is for error, and hence the more likely it is that what one says is true. So modesty is rather obviously a theoretical virtue. It makes a theory more likely to be true." Now that seems right. A theory says less and is therefore more modest than a competitor when it is less specific or narrower in scope than the competitor. A hypothesis that states that there is a person behind the door, is more modest than a hypothesis that states that some particular person, say Richard Swinburne, is behind the door. The second hypothesis asserts everything that first hypothesis did, but it goes further, it asserts more detail. And given its content, there are more ways that the second hypothesis could turn out to be false than for that first hypothesis to turn out to be false. Now, of course, in this comparison, these hypotheses are not strictly incompatible, right? Both could be true. However, we can also compare the modesty of two incompatible hypotheses. Consider the number of stars in the universe, right? One hypothesis says that the number of stars in the universe is even. The other says that the number of stars in the universe is odd. These two are going to be roughly equal in terms of their modesty, in that they both seem to say the same amount about the universe. But suppose that we modify that second hypothesis, and we say that the second hypothesis is that the number of stars in the universe is odd, and that most of them also have an odd number of planets orbiting them. We don't actually need to know anything about the actual number of stars or the actual number of planets orbiting them to recognize that the second hypothesis asserts much more. It has much more content. It sticks its neck out even further than the first hypothesis, and thereby makes itself more likely than the first hypothesis to be saying something false. And for that reason, we can clearly see that the first hypothesis is more modest. So again, that's how we should think about modesty here, as being inversely related to how much a theory asserts. This brings us to the second part of Draper's theory of intrinsic probability. While a theory's modesty concerns the scope, the specificity, and the number of conjuncts in what it says, a theory's coherence concerns how well those various parts fit together through known deductive or inductive support relations. As with modesty, coherence too comes in degrees. If a theory has parts that enjoy strong deductive or inductive relations between them, it will be more coherent than a theory whose parts have zero or very little weak support relations between them. In a 2016 article titled Simplicity in Natural Theology, Paul Draper writes, quote, "At one end of the spectrum are necessary falsehoods, which have contradictory parts and so are maximally incoherent. Notice that such statements entail everything and so are maximally immodest as well. At the other end are necessary truths. A necessary truth is maximally coherent because each of its parts entails every other part. And since such hypotheses tell us nothing about the world that could be false, they are not just maximally coherent, but maximally modest as well." Unquote. Draper goes on to illustrate his notion of coherence with the following two statements. The first statement is, all Asian crows are black, and all non-Asian crows are black. The second statement is, all Asian crows are black, and all non-Asian crows are white. The first thing to note is that these two statements are taking a stand on something equally specific. Not only that, but they are asserting something equally specific about the same class of things, i.e. the entire crow population. All that is to say that they are identical in their modesty. Now, should we conclude that because they are equal in terms of their modesty, that they must therefore be equal in terms of their intrinsic probability? Well, no, that would be to ignore coherence. Look again at those two claims. Notice that the first part of the first statement inductively supports the second part of that first statement, but that this inductive support relation is wholly absent in that second statement. The first part of that second statement in no way supports the second part of that second statement. Logically speaking, the second part of that second statement appears to come completely out of left field. And because of that difference and how well the parts of the statements support each other, the first statement is more coherent than the second statement, even if we can clearly see that they are also equal in terms of their modesty. As Draper notes, quote, hypotheses that attribute real uniformity to the world are to that extent more coherent and thus more probable intrinsically than hypotheses that attribute real variety, either at a time or over time, unquote. Now, the third tenet of Draper's theory of intrinsic probability draws a line in the sand, stating that nothing else determines it. It's a kind of closure principle. His justification for this third tenet appeals to the fact that there appears to be nothing left to consider that could determine a theory's intrinsic probability. Motivating this hard line, Draper writes, quote, if we abstract from all factors that are extrinsic to a hypothesis, i.e., all confirming and disconfirming data, arguments, and perceptions, focusing only on what is intrinsic to the hypothesis, then what else could its probability depend on other than how little it says and how well what it says fits together? So that's Draper's analysis of intrinsic probability. Now, of course, once we move past the question of intrinsic probability and we start to look at the available evidence, it may turn out that the more modest and coherent, and therefore the more intrinsically probable of two hypotheses, is nevertheless less probable overall. Hypothesis A can have an advantage of being intrinsically more probable than hypothesis B, even if theory B ends up winning out on, say, evidential concerns. Returning to our race analogy, this would be like a runner who is given a head start, but nevertheless loses because he's much slower than his or her competition. The moral of the story being that when we are comparing theories, we've got to look both at factors that are extrinsic to them and factors that are intrinsic to them. This has been a brief overview of Paul Draper's view of intrinsic probability. Thanks for watching, and please remember to like this video and to subscribe.